My name is Ishul Abdul Halain. Welcome to my video on the PIC16F877A Embedded C Program Basics. We will be looking at what an embedded system is and also discuss the structure of an embedded C program. An embedded system is defined as a smart system comprising of both hardware and software that work together to perform a specific task. Let's have a look at an example of what I mean. Consider a fully autonomous quadcopter drone as an embedded system. It's composed of a carbon fiber fuselage with 4 arms designed to look like the letter X. A microcontroller chip is mounted on the fuselage to control the drone. Electronic speed controllers are mounted on every arm. These devices output variable high currents, usually in the range of 10th of amperes. They are used to drive 4 brushless motors mounted at the tip of every arm. The microcontroller is connected to the electronic control unit to control its output current, which in turn controls the speed of the brushless motors. A global positioning system module is also mounted on the frame and connected to the microcontroller. This sensor will allow us to know the drone's position in 3D space. A radio transmitter receiver module is also attached to the microcontroller for the drone to transmit video it has captured using the onboard camera module that is also controlled by the microcontroller. The radio transmitter receiver also allows the drone to receive signals that control the camera module. Each brushless motor is fitted with a propeller that provides lift and thrust for the drone. Finally, a high current discharge battery is included in the hardware of our drone. A flight controller software, usually written in embedded C language, is written and uploaded into the microcontroller to control all of the hardware components of the drone. Thus, this drone consists of both hardware and software, making it an embedded system. Embedded C is a high-level programming language used to design software for embedded systems. It's called embedded C because the software is embedded in a microcontroller that is also embedded in a system of devices that it controls. Examples of where you will find embedded C are in drones, washing machines, home security systems, digital multimeters, or even in the Iron Man suit. As you know, the Iron Man suit is controlled by a software named Jarvis. I think Jarvis was designed using embedded C. On the other hand, C program is used to design application softwares that run on a computer. Examples are Adobe Illustrator, a program used for drawing, PowerPoint, for producing slides and videos like this, a calculator software on your phone, the Brave web browser software, the camera apps on your phone, and WhatsApp, just to name a few. So, we conclude that the major difference between embedded C and C is their application. They also have minor differences in their program structure or construct. But this difference is so small that you can easily write an embedded C program if you know C programming. PIC programming is a two-step process. The first is writing firmware, which is the software used to control your PIC microcontroller. For this, you will need some sort of a computer installed with an embedded C compiler. It is a program that you can use to write firmware for your target microcontroller. The compiler's input is the embedded C program that you wrote. It compiles and translates your .c file into machine language comprising of ones and zeros. For the 16F877A chip, 14 bits of ones and zeros constitutes one instruction. Anyway, the compiler also outputs a hex file, which is nothing but the machine codes formatted neatly in its equivalent hexadecimal values. The output file's extension is .hex. You will need this file in the next step to program your PIC. The second step is to upload your firmware into your target microcontroller. The firmware is loaded into the PIC's program memory block. You will start by connecting your computer to a PIC programmer. It is just a device that supports serial data transfer from your computer to your microcontroller. You will then connect the PIC programmer to your microcontroller. For the PIC16F877A, this will be pin 1, 13, 14, 36, 39, and 40. You can have a look at the data sheet what these pins are used for. The next step is to open the PIC programmer software in your computer and load it with your hex file. Once you give the command, your hex file will be programmed into your microcontroller. Those were the 2 steps needed in PIC programming. Easy peasy, lemon squeezy. Let's have a look at the structure of an embedded C program using this example. The first line is where the header file is inserted using the include preprocessor directive. Notice that the file name is not stdio.h like in C. For this program, its name is 16F877A.h because this program is written for the PIC16F877A chip. Since the programmer is responsible to write this header file, it is up to you to name it anything that you like. Also note that the file extension is a .h. The header file in embedded C is used to provide the compiler with 3 types of information regarding the target microcontroller. The first is the location of all of the special function registers that you will use in your program. It is obtained from the register file map in the datasheet. This is part of the contents of the header file that you use to define the special function registers used in your program. In the first column you have the names of all of the registers in the register file circuit. They are treated as special variables when compiled. In the second column, you have the EQU directive that is used to assign register names to its addresses. In the third column you have the physical addresses of each corresponding register. Now look at the 3 columns together showing the syntax on how to link the special register's name to its address. Do you see how the register's name is equated to its corresponding address? I hope it makes sense to you. So, the header file contains special variable names similar to the special function registers in the register file. This information allows you to use the special function registers just by referring to its name like any other variable in C. The second contents of the header file is the instructions to set the configuration bits of your PIC microcontroller. The configuration bits are either turned on, or off, to enable or disable special microcontroller on-chip features that we will discuss in the next slide. These are the instructions used to set the configuration bits. It uses the pragma preprocessor directive followed by the config keyword. Config is short for configuration and is followed by the register name for a particular feature that you see here. It is equated to on, to turn on a feature, or off, to disable a feature. You should only use features you need in order to reduce power consumption and to guarantee a smooth running microcontroller. Finally, you will also declare the clock frequency of your chip using the define preproxer directive in your header file. It is followed by the keyword xtol-frac as shown here. It stands for crystal oscillator frequency. This is followed by the frequency value that you wish to run at. Mine is 20 MHz. So, these are the 3 items required in our header file. Back to the structure. The next line is declaration of global variables used in your program. The following line is for customized functions that you have written. The difference in function declaration between C and embedded C is that in embedded C, a function prototype is not required. You just simply define only your function block. Cool. Finally, you will have one main function in your program. In it you will have an infinite loop that is implemented using a while one loop. Once your program executes, the statements contained in the while one block will be executed until you turn off your microcontroller. That's all for the program structure. Let's see what goes into selecting the on-chip special features. This is done using the configuration word register located at address 2007 in the program memory block. The special features are oscillator selection to select between the use of an on-chip or off-chip master clock, a watchdog timer feature to detect and recover from computer malfunctions, power-up timer feature for regulating timing during power-up, brownout reset feature that protects the system if the power supply falls beneath a certain level, low voltage programming feature for programming the PIC using only the chip's VDD supply voltage, EEPROM code protection feature to protect your program from being overwritten, program flash memory write enable feature to select microcontroller programming mode, in-circuit debugger feature for debugging your program while it runs in real time attached to its hardware components, and flash program memory code protection feature to protect your program loaded in the program memory block of your microcontroller. As shown previously, you will access the configuration word register to select your desired features using these instructions that is placed in your header file. That's the basics about embedded C programming for the microcontroller. We have seen what an embedded system is. It's simply devices controlled by a microcontroller that you have programmed to do a specific task. We have also seen what a header file in embedded C contains, which are the SFR locations, configuration bit settings and master oscillator setting. I hope you have learned something new. Have a nice day.